Calculus students and particularly general seekers of truth. We get to the end of this lesson with maybe a very challenging example, if especially if we're not working with a calculator. Even with the calculator, this requires quite a bit of thought, which is why it is such a wonderful problem. So we want to compare two functions, f of x equals log base 2 of x, and g of x equals log base 5 of 9x squared plus 1. And so at first this is very daunting. You have different bases. You have a multiplier here. You have an x squared instead of an x, and then you have a plus 1 at the end. So one of the things that I will do first here is try to get everything into the same base. So I will hopefully jog your memory a little bit. On the side here, I will give you some notes and some ideas on what we can do. So on the side here, so the first thing that we're going to do is change bases. And so changing bases. These are strategies or ideas that will help you think through this and work through this a little bit better. So we're going to change the base of g of x. Now, remember that we can always change the base by using the natural log. So log base 5 of anything is really, I don't know why I said natural log, is really log base 2 of 9x squared over log base 2 of 5. So this is the change of base rule. You might want to review it in one of the previous lessons if this is a little bit rusty. And then we still have this plus 1 at the end here. And maybe you're thinking, why do we do this? Well, one of the nice features of this is we can pull out that log base 2 of 5 here because this is a constant. That's all I have to worry about here is that I have a constant multiplier in front here. So I can think about this in terms of transformations. And I've accomplished something very nice, namely I get this base and this base to be exactly the same. Okay, so log base 2 and log base 2. All right. So now I want to deal with this x squared here. Okay. So this x squared here isn't too difficult to deal with. We need to apply some more laws of logarithms. So get that constant, they're still all the same. This is log base 2. And I want to pull this 2 out to the front, but this square here, it only applies to the x. It doesn't apply to the entire quantity inside. So you take the square root of that constant, group it together, and square this. So all I'm doing here is rewriting, so all I'm doing is, again, rewriting 9x squared as 3x quantity squared. And what this allows me to do, let me change colors here so we don't get too mixed up. So the constant is still there, 1 over log base 2 of 5. Okay. And now I can take this 2 and pull it out to the front. This is the power rule. So 2 here, what I'm doing in the second step here is using the power rule of logs. Okay. And then I have still a log base 2 of 3x. And I'm going to just kind of mash this all together. 2 over log base 2 of 5 times log base 2 of 3x. And at this point, it is actually enough for me to be able to answer the question, going from the original f of x to g of x. We've rewritten this, enough so that we can actually solve it. I mean, answer the question now in terms of transformations. So let's see. The log base 2 of 5 is a number that is a little bit larger than 2. Okay, so because log base 2 of 4 is 2. So I have 2 over a number bigger than 2. So this part right here is less than 1. So that means this must be a shrink, a vertical shrink. In order to go from f to g, I have to perform a vertical shrink by a factor of 2 over log base 2 of 5. And then just one more change in here. This is going to get quite colorful. This 3 right here, it modifies the input of the log function. So this is going to be a horizontal transformation. And remember, horizontal transformations are kind of backwards intuitively from vertical ones. So when we multiply by 3, we're actually shrinking horizontally by a factor of 1/3. And there you have it. So these two functions, even though they're very, very different looking algebraically, graphically they're going to be very similar. You're just stretching it vertically a little bit, and then you are shrinking horizontally a little bit. Now I made a small mistake here that's very common, which is I forgot this +1 in all of my complicated work. I forgot to add this +1. So that +1 there that we have, from the original part of the problem, that is a shift up 1 unit. And I'll leave it to you to graph this and see this for yourself. I want to focus mostly on the algebraic and the transformational aspects of it, because I want you to understand transformations and apply them to these types of problems analytically. As always, ask for help if you need it. Thank you for watching, and have a wonderful day.